So towards saving, what we have to do is we'll save them as a test.lsp, but we have to make sure that this save as file type should be in all files so that it will save at a LSP file, because only when it is a LSP file, then AutoCAD itself can understand that it's a Lisp routine file. So now we'll go ahead and save. So that's it. So we have done. So we have now created the code on a textual editor and then saved it as a LSP routine. So now let's recall and see what are the different methods that we can call within the function. So we have two methods within the command line to call the function. The first is the load methodology, where we have call it by load command followed by the path of the command. We have to explicitly type the path. And second one is using an AppLoad functionality, wherein you get a dialog box kind of environment where you can locate the file that is of interest to us. So let us first start off with the basic command. So that again, as we know, all the Lisp routine starts with the open and close parenthesis. Now we call the function. This is the function name, load. So next is we have to call the path within this double quotes. So here we cannot directly call the path, because AutoCAD itself will have to refer to a path from which it has to search a file. Only if it is present within its library, then you can call the file name directly. But as you could recollect, the textual file that we have created is located in our desktop. So for that, you have to call the entire address of it. So towards taking the address, let us see that this is the file that we have created, test file. Okay. So in this manner, for understanding the address, we can go for the properties and you can see that this is where the file location is. So let us copy it. Let us copy this address. Now let's go back to this path. Now click it onto here and followed by the file name. So this is our file name, test.lsp. So LSP is not required because this load automatically goes and look for this file. So even it's not explicitly mentioned, it should not be a problem. So once we click on this, you can see that it prompts us that the load has failed. Why? Because you can see a clue here. In this command line, you can see that once this backslash is prompted, but now this backslash is not visible and it is available only here. So this is what the clue to is. AutoCAD, when calling for load option, it cannot treat the slash symbol. So we have to explicitly specify two slashes to indicate the path of it. So now once executed now it clearly takes in the location. As it is a user-based Lisp file, now AutoCAD says that the publisher details cannot be verified, should we load or not. So let us go once, always load. So now you can see that the file has been successfully loaded, and as a notification of that, you can observe that the C:(test) has returned. So this is a successful example of saying that the file has got loaded. So now let us go ahead and call this function. So in order to call this function, you just have to type in directly. So you can see that once it is executed, your zoom has executed, it has zoomed to all, and now the next prompting for the center point of the circle. So now upon clicking it, now the command is completely executed. So this is one simple example of how to use an AutoLISP routine to quickly make sure you execute the task, this set of tasks, because right now you have done your own function. As you can see, when you call the test, it is available with the rest of the commands that are available. That is, you have defined your own function into the AutoCAD environment. So this is the powerful functionality of an AutoLISP, to define your own custom commands. So congrats to you. So now this is your first AutoLISP routine. So now we can see how well we can explore this. But before this, we'll also see the other functionality of using this AppLoad. So this is an application load functionality wherein you can get a user interface kind of thing, where you can specify what are the functions that you want to load and unload. So as you can see here, what are the already existing loaded functionalities that are within this thing. So you can see this function test that we have loaded from the desktop is already loaded here. Likewise, there are several other Lisp routines that have been loaded. So this is one way of selecting it. So now what we can do is we can directly go to the location that we want to do and then click on it and then click on load. So now we can see that this test.lsp successfully loaded info from the menu. So with this you can load a sequence of Lisp routines continuously, and then once you have loaded everything, then you can close it out. Also, one more advantage what we have here is using this AppLoad functionality, you can also configure that to load it as a part of your AutoCAD startup itself. So that means that you can add all the Lisp routines that are of frequent use to you as a part of this startup functionality, so that once you open AutoCAD, all the lists that are displayed here will get loaded automatically. So this is how you will call using this Lisp routine itself. So now we look into what is this Visual LISP Editor is about and how we can use it. So actually that is the most preferred way of doing it. Suppose if you are developing the Lisp coding for the first time or want to run it through different iterations to finalize it. So Notepad editor is a good thing if you are very clear about how you are going to proceed about and then do it. But as we said earlier, this is not an IDE based environment of this AutoLISP. That is, it do not have a single setup where you can do all the operations together. But close to something like that is your Visual LISP Editor, wherein you can start typing in it and then look into how your code progresses step by step. That is one sort of, not a complete debugging in terms of software coding language, but at least you can see how your coding proceeds from one step to other so that you can take informed decisions on it. So this Visual LISP Editor is available in your Manage ribbon and here in Applications as Visual LISP Editor. Also, in Tools, you have this AutoLISP. Here you have the Visual LISP Editor. So in order to go there, you just click on this Visual LISP Editor, and you can see that what are the different consoles what we have here. So let us just let me just open it up fresh. So one thing is that what you can see here is the overall operation pane. You have the toolbars here, and we have three major segments. We have the console here. We have the console where we can execute the course directly. You can see that it's preceded by a dollar symbol here. And also we have a functionality called as a trace that it can look into the background functionalities. And next is the functions where you type in the code, the Lisp text file. So this is how it is structured. So you can right away use this console to see how it is executed by this function. Suppose if we have to execute these two commands, you can see that instead of going to the AutoCAD environment, the execution can be witnessed here. So this is what this console is all about. So it's typically a replication of the command line that you have there. So next is, let us go ahead and then now try using a new file that we want to create and see how it is executed. So let us type in the code again, the fundamental code that we have seen. So we'll use dfun C:\test1, let us name it that way. And I'm just quickly typing out the commands here, but have a note on the color icons that are being visible here. You can see that there are different colors that are being taken care. So you can see it here. Now we'll also introduce one command line. This is a comment, and then closing out. So this is the major advantage that you use in a Visual LISP editor, wherein we can visualize see how the different type of data characters that you're using, whether it's a system variable or a string or an integer or a user-defined function, all is being showcased by the differential of the icons or the color font that you have. So as you can see here, system commands are all highlighted by blue color here. The text is in blue color for all system-based commands. So this command defun is all a system variable. Whereas user-defined function variables here you can see that it is in black color. And all open and closed braces are in red, and strings are in pink, and integers are in green color. So this is one type of differentiation what you can see during your coding operation, so that you can categorize them easily. And also you can see that once you start typing and editing your command, the indenting will happen automatically, so that as it enters a function you can see that it has got intended in this manner, that is it has moved. There are empty spaces automatically assigned to it, so that it improves the readability of the text. Whereas in a notepad or in a custom text editor you have to manually put in all those specifications. So this is one thing that can come out of this Visual LISP editor. So now having created that, you can save it using this Control S option. So now as you could see, it automatically lists the save as a Lisp source file. So let us say that it is a test1 again, test1 Lisp that is stored in desktop. So now you can see that it is stored here. And once you click on this text file, you can see that there are some icons that are highlighted here. Let us look into one by one now. So we'll just take this menu first. You can see that this is the tools menu. And next we have here is the view menu or the view toolbar. And here is we have the debug toolbar. And this is a search toolbar. And this is our normal edit toolbar. Standard toolbar here available. So these are the different toolbars that are available. So when you take it out, you can see it clearly. So now on clicking onto this list window, you can see that the tools is highlighted. Whereas if you move over to the Visual LISP console, you can see only the view icons are highlighted and search are highlighted. And again the debug is not highlighted here. So this is how the functionality of different windows will is highlighted based on the selection. So now we can see that once we have selected this Lisp file, first off we can see in the tools function, we can see that this is the load of the file, load the active Visual LISP onto this thing. So once you click on it, you can see that this has got loaded into the Visual LISP. So, and next thing is we can see that this is the loading the selection. So right now it is just loaded onto the console. So right now if you click on it, this file will get loaded onto your console directly. So next is this is the to checking the whether the load is being the output is okay or not. So this again is an interpreter. It just looks into whether it's all the commands lines are okay or not. Whereas if you go for a proper folder, then you have to compile it, then it will run all the checking and then do it. So this is just an overall check parameters. Whereas if you click on this, so what you see here was when we click this icon, the entire Lisp program will get loaded onto here. Whereas we can load only one specific line for the selections that we want by highlighting, selecting them and then click on this icon. Load only selection. So only this line has got loaded. So by that you can load or unload whatever group of functions you want. Suppose if you are nesting function within a different function, then you can use this selection option loading to particularly load a part of the program, not the entire program, and then run only that. And again, you can run whether the checking of the verification of the program by a single line. Suppose if you want to check only this line, then you can click on that selection and then click on whether it is okay or not. Suppose let us say we have made a mistake like this, and then click on the selection here test. You can see that an error has thrown, and it shows that a malformed string on input is highlighted. So by this way, this is an indirect method of debugging the code. So let's see how this debugging can be actually taking place inside this coding environment to check whether the written code is okay or not. So towards debugging, it's what you have in this debug icon. So here you can see that the highlighted icons are the watch, the add breakpoint, and then stop icon. So towards this, you can also see it here. You can see the add watch, toggle the breakpoint, and then continue. So here we'll put a toggle breakpoint here. That is the F9 button, adding a breakpoint. So for now, let us get back all this command button here and then now see one by one. So to ease of you, we'll just keep it in this way so that let us see now what happens first. So in order to execute it, we'll run this code. So now this file has got loaded. Going back, clicking on here and then click on test one. Let us see, call the function. Now it has zoom all, and then now it is asking for the center point and then executing. Well, this is how it has executed. So now, but it has happened rather faster. So that's where your breakpoint will help you to look into what is happening. So let us just give 2 breakpoints to these activities here. Okay, so now let us load it back and maybe move it to somewhere here, and now execute the code again. So now you can see that the cursor now stops at this point. So it is stopping at this command line and waiting for the next step to happen. So now we'll go into step 2. Now you can see that it is zooming into the overall extent. Now it is going back to the screen what we have here, and see the command is coming to the end of the parenthesis there. That is, this command has got executed. So now let us go into the next step. Now this is the step that has to get executed. Going back into again. Now it is pausing for the user input. So now let us say this is the center point that we have, and now this command has got executed. So now going back again to the next step is what the complete command has got executed. So this is the straightforward way of doing a debug action. So to catch it still further, so you can see what other methodologies that we can do is we have something called as a watch function here. So this is useful to see what user defined variables are assigned to, what are the characters that are assigned. Suppose let us, instead of waiting for a user input here, let us say that instead of pausing for it, let us define a center point. Okay. So and for analysis purpose, we just keep it as 50 here. So now we will use the system variable setQ space, and then what is the variable name is center, and towards that you for setting this variable you get a point, call in a system variable function. So we'll again toggle a breakpoint here and see what's happening. So now let us put this code fully, and now let us step into it. Yeah, so towards it we'll just call for let us just test run. So let us quickly come out of this breakpoint. So let us exit this. So now let us run it here. Okay, so back again. So now it is going into the breakpoint mode. Let us come back. So now, as we call for, it is going into this step mode. Now let us go to the next part, and it is zooming on and stepping into again. Now it is asking for a center point. It is going for this line. Let us step into again. Now it is where it is expecting the get point variable. So now let us step into here. It is asking for a center point. So now that center point was obtained, and now let us go to the next command, and next command. So this is how it is. But currently we are not sure of what was the center point, right? So towards this is what we can, select this out and then click this glasses icon. So this is the watch. So once you click on it, you can see that variable, what was the previous value to that variable is that. So it means that you can see also the last value. So when we first defined this, its value was in nil, and next once we click on it, the value was updated to 430. So right now let us do it once more. We'll call this variable function again. Come out of the debug mode, and now let us call the function. So it is getting into the first signal. So now let us skip this step, and second point. So it is going into the set point. Now we can see that the prompt has come here, and let us say this is the command. We just have a note on what is the previous value here. So now let us say this is what the value is, and you can very well see that the watch function now updates the coordinates that we have here, and going on to next, we are finally coming out of this code. So this is the functionality that you can get out of this watch command. So this is in short putting together the functionality of the Lisp console to systematically verify each part of your code one by one using this debug command, watch command, and toggle breakpoint command, and also that you can thoroughly investigate what are the problematic steps that you are facing. And going by again, suppose if we have some error, suppose if we have missed out one point here, and this very well, once you run this, you can see that that's an error that is showing out here. So this can also help you to quickly analyze what is happening, but by adding breakpoint to certain set of modules, you can verify at which point it is getting stuck. Because generally you are saying that you can see that this error malformed list on input is shown here. When execution, it will exactly show with breakpoints, it will show which is where. So this is where this Visual LISP is a value addition to your Lisp programming, because you can keep on building small modules, test them right away in your AutoDesk environment here, and then once you are done with it, then you can save it as a whole, and next you can directly, once you build on it, you can use this AppLoad functionality that you have here to call those functions one by one. Then also, as said earlier, using the startup menu, you can configure which are the Lisp functions that you are using over and over again, so that you can configure it totally. So this is a summation of the Lisp coding what we have here, and this Visual LISP environment might look a little bit old. That's right, because initially it was a very powerful functionality that builds over the AutoLISP. This Visual LISP builds over the AutoLISP function so that you can develop your own complex modules. But then as a part of, from 2000 onwards, the development activity stopped. So that's why you can also see that it's pretty much kind of a vintage version that is looking at it, but still the functionalities, the background functionalities are still there. So this is how you can use the Visual LISP to create user-defined functionalities. So with this, we'll conclude this part of AutoCAD and see you in the next week. Thank you.